In chemical nomenclature, the IUPAC nomenclature of inorganic chemistry is a systematic method of naming inorganic chemical compounds, as recommended by the International Union of Pure and Applied Chemistry (IUPAC). It is published in Nomenclature of Inorganic Chemistry, which is informally called the Red Book. Ideally, every inorganic compound should have a name from which an unambiguous formula can be determined. There is also an IUPAC nomenclature of organic chemistry. System. The names caffeine and 3,7-dihydro-1,3,7-trimethyl-1-H-purine 2,6-dione both signify the same chemical. The systematic name encodes the structure and composition of the caffeine molecule in some detail, and provides an unambiguous reference to this compound, whereas the name caffeine just names it. These advantages make the systematic name far superior to the common name when absolute clarity and precision are required. However, for the sake of brevity, even professional chemists will use the non-systematic name almost all of the time, because caffeine is a well-known common chemical with a unique structure. Similarly, H2O is most often simply called water in English, though other chemical names do exist. Single-atom anions are named with an "ide" suffix, for example, H- is hydride. Compounds with a positive ion cation, the name of the compound is simply the cation's name, usually the same as the elements, followed by the anion. For example, sodium chloride is sodium chloride, and calcium fluoride is calcium fluoride. Cations which have taken on more than one positive charge are labeled with Roman numerals in parentheses. For example, Cu+ is copper I, Cu2+ is copper 2. An older, deprecated notation is to append Ous or Ic to the root of the Latin name to name ions with a lesser or greater charge. Under this naming convention, Cu+ is cuprous and Cu2+ is cupric. For naming metal complexes, see the page on complex chemistry. Oxyanions, polyatomic anions containing oxygen, are named with ITE or 8, for a lesser or greater quantity of oxygen, respectively. For example, NO-2 is nitrite, while NO-3 is nitrate. If 4 oxyanions are possible, the prefixes hypo and per are used. Hypochlorite is ClO-, perchlorate is ClO-4. The prefix bi is a deprecated way of indicating the presence of a single hydrogen ion, as in sodium bicarbonate, sodium hydrogen carbonate. The modern method specifically names the hydrogen atom. Thus, sodium hydrogen carbonate would be pronounced sodium hydrogen carbonate. Positively charged ions are called cations and negatively charged ions are called anions. The cation is always named first. Ions can be metals, non-metals or polyatomic ions. Therefore, the name of the metal or positive polyatomic ion is followed by the name of the non-metal or negative polyatomic ion. The positive ion retains its element name, whereas for a single non-metal anion the ending is changed to "ide". Example, sodium chloride, potassium oxide, or calcium carbonate. When the metal has more than one possible ionic charge or oxidation number, the name becomes ambiguous. In these cases, the oxidation number, the same as the charge, of the metal ion is represented by a Roman numeral in parentheses immediately following the metal ion name. For example, in uranium fluoride the oxidation number of uranium is 6. Another example is the iron oxides. FeO is iron oxide and iron oxide is iron oxide. An older system used prefixes and suffixes to indicate the oxidation number, according to the following scheme. Thus the 4 oxyacids of chlorine are called hypochlorous acid HOCl, chlorous acid HOClO, chloric acid HOClO2, and perchloric acid HOClO3, and their respective conjugate bases are the hypochlorite, chlorite, chlorate and perchlorate ions. This system has partially fallen out of use, but survives in the common names of many chemical compounds. The modern literature contains few references to ferric chloride, instead calling it iron chloride, but names like potassium permanganate instead of potassium manganate and sulfuric acid abound. Traditional naming. Naming simple ionic compounds. An ionic compound is named by its cation followed by its anion. See polyatomic ion for a list of possible ions. For cations that take on multiple charges, the charge is written using Roman numerals in parentheses immediately following the element name. For example, copper-2 nitrate is copper nitrate, because the charge of 2 nitrate ions No-3 is 2 times -1 equals -2, and since the net charge of the ionic compound must be 0, the Cu ion has a 2+ charge. This compound is therefore copper nitrate. In the case of cations with a +4 oxidation state, the only acceptable format for the Roman numeral 4 is IV and not 4. The Roman numerals in fact show the oxidation number, but in simple ionic compounds, i.e., not metal complexes, this will always equal the ionic charge on the metal. For a simple overview see 1. For more details see selected pages from IUPAC rules for naming inorganic compounds. List of common ion names. Monatomic anions: Cl-chloride, S2-sulfide, P3- polyatomic ions, NH+4 ammonium, H3O+ hydronium, NO-3 nitrate, NO-2 nitrite, ClO- hypochlorite, ClO-2 chlorite, ClO-3 chlorate, ClO-4 perchlorate, SO2-3 sulfite, SO2-4 sulfate, HSO-3 hydrogen sulfite or bisulfite, HCO-3 hydrogen carbonate or bicarbonate, CO2-3 carbonate, PO3-4 phosphate, HPO2-4 hydrogen phosphate, H2PO-4 dihydrogen phosphate, Cro2-4 chromate, Cr2O2-7 dichromate, BO3-3 borate, ASO3-4 arsenate, C2O2-4 oxalate, CN- SCN-thiocyanate, MnO-4 permanganate. Naming hydrates. Hydrates are ionic compounds that have absorbed water. They are named as the ionic compound followed by a numerical prefix and hydrate. The numerical prefixes used are listed below. See IUPAC numerical multiplier: mono, di, tri, tetra, penta, hexa, hepta, octa, nona, deca. For example, copper 2 sulfate 5H2O is copper 2 sulfate pentahydrate. Topic: Naming molecular compounds. Inorganic molecular compounds are named with a prefix, see list above, before each element. The more electronegative element is written last and with an "ide" suffix. For example, H2O water can be called dihydrogen monoxide. Organic molecules do not follow this rule. In addition, the prefix mono is not used with the first element, for example, SO2 is sulfur dioxide, not monosulfur dioxide. Sometimes prefixes are shortened when the ending vowel of the prefix conflicts with a starting vowel in the compound. This makes the name easier to pronounce, for example, CO is carbon monoxide, as opposed to monooxide. Common exceptions. There are a number of exceptions and special cases that violate the above rules. Sometimes the prefix is left off of the initial atom. I2O5 is known as iodine pentoxide, but it should be called diiodine pentoxide. N2O3 is called nitrogen sesquioxide. Sesqui means 1.5. The main oxide of phosphorus is called phosphorus pentoxide. It should actually be diphosphorus pentoxide, but it is assumed that there are two phosphorus atoms, P2O5, as they are needed in order to balance the oxidation numbers of the 5 oxygen atoms. However, people have known for years that the real form of the molecule is P4010, not P2O5, yet it is not normally called tetraphosphorus decaoxide. In writing formulas, ammonia is NH3 even though nitrogen is more electronegative. Likewise, methane is written as CH4 even though carbon is more electronegative. Nomenclature of inorganic chemistry. Nomenclature of inorganic chemistry, by chemists commonly referred to as the Red Book, is a collection of recommendations on IUPAC nomenclature, published at irregular intervals by the IUPAC. The last full edition was published in 2005, in both paper and electronic versions. See also IUPAC nomenclature, IUPAC nomenclature of organic chemistry, List of inorganic compounds, Water of crystallization, IUPAC nomenclature of inorganic chemistry 2005, The Red Book, Nomenclature of organic chemistry, The Blue Book, Quantities, Units and Symbols in Physical Chemistry, The Green Book, Compendium of Chemical Terminology, The Gold Book, Compendium of Analytical Nomenclature, The Orange Book.